I want to start with a specific memory. It wasn't that long ago. Maybe, 4 or 5 years. You're offshore, maybe on a charter, could be a commercial vessel. You need to send one single file, not a movie, just a PDF. You hit send, and then you just stare at the screen.
Well, the progress bar that never moves.
It was almost meditative in how frustrating it was. That spinning wheel was basically the logo for Maritime Internet. You paid a fortune for it, and it barely worked. It was this barrier that kept the ocean effectively disconnected from the rest of the world.
It was a bottleneck, a very expensive, very narrow bottleneck.
But today, we're looking at the technology that basically popped the cork on that bottle. We are doing a deep dive into Starlink Marine. And I know everyone has heard the hype streaming 4K in the middle of the Pacific.
Right.
But looking at the technical documentation and, the installation guides you brought in, the reality is a little more complex than just plug it in and watch Netflix.
That's the marketing pitch. The reality is that while the satellite technology is revolutionary, and I really don't use that word lightly, the implementation on a moving vessel is. It's an engineering tightrope walk. We need to talk about physics, we need to talk about network architecture, and we definitely need to talk about why buying the kit is actually just step one.
Okay, so let's start with the physics, because for the longest time, satellite internet was just bad, inherently bad. Why was it so hard to get a decent signal at sea before now?
It really all comes down to geometry. The old way, the legacy marine internet, it relied almost entirely on geostationary satellites, or GEO.
Those are the ones parked in a fixed spot, right?
They sit way up above the equator, and they match the rotation of the Earth, so from our perspective, they seem stationary. But to do that, they have to be very, very far away. We're talking about 35,000 kilometers up.
35,000 kilometers, that's a significant distance.
It's massive. And even at the speed of light, a signal has to travel from your boat all the way up to the satellite, bounce back down to a ground station. It goes to the internet server, comes all the way back in the ground station, up to the satellite, and then finally back to your boat.
And that entire trip takes time.
A lot of time. We call it latency. On those old systems, you were looking at, 600 to 800 milliseconds of delay.
Which, to a human, that sounds fast. I mean, less than a second. But for a computer,
it's an eternity.
Yeah.
The internet relies on these little handshakes. Your computer says, hello. The server says, hi back. Your computer says, I'd like this image. The server says, okay. When every single one of those handshakes has nearly a 1-second delay, the whole experience just feels sluggish. It's why web pages took forever to load, and it made things like Zoom calls or, remote desktop just impossible. You'd be talking over each other constantly.
So the Starlink approach, the low Earth orbit, or LEO, that changes the math.
It changes the math drastically. They brought the satellites down from 35,000 kilometers to about 550 kilometers.
That's huge. That's like moving from the other side of the country to the house next door.
And the latency just drops with it. We go from 800 milliseconds down to maybe 20 to 40 milliseconds.
So that's comparable to a decent fiber connection on land.
Exactly. Suddenly, those handshakes happen instantly. The sluggishness just disappears.
It sounds perfect.
It changes the utility of the connection. It goes from emergency emails only to an extension of your office. But there is a catch.
There's always a catch.
When you are 35,000 kilometers away, you can see nearly a third of the Earth with one satellite. You don't need many of them. But when you are only 550 kilometers up,
you can only see a tiny patch of the ocean.
Right, which means you need thousands of satellites to blanket the planet. And because they're so close to Earth's gravity well, they have to move incredibly fast to stay in orbit. We're talking about 17,000 miles per hour.
So unlike the old TV satellite that just sat there, these things are just screaming across the sky.
They cross from horizon to horizon in a matter of minutes.
This was the part of the technical guides that I found most fascinating, the hardware. Because in the old days, if you wanted to track a satellite, you had those massive domes. I've seen them on super yachts. They look like giant mushrooms.
VSAT domes.
Oh.
And inside those, there was a dish on a gimbal with motors and gears physically spinning and tilting to keep pointed at that one spot in the sky while the boat rocked and rolled.
And putting moving parts in salt air just seems like a really bad idea.
It's a maintenance nightmare. Gears wear out, motors burn out, belts snap. But the Starlink flat high-performance antenna, the one designed for maritime, it has no moving parts.
Wait, hold on. If the satellites are whizzing by at 17,000 miles per hour and the boat is bobbing around in the waves, how does a flat stationary panel track the signal?
It uses something called a phased array antenna. Think of the old dish like a spotlight. You have to physically grab it and turn it to point the beam. A phased array is more like a grid of thousands of tiny little LEDs. By micro-adjusting the timing of the signal from each of those tiny chips, the antenna can steer the beam of data electronically.
So it's manipulating the signal itself to point in a direction without the hardware ever actually moving.
It creates a beam that can sweep across the entire sky in milliseconds. It can track a satellite moving incredibly fast while simultaneously compensating for the boat pitching in heavy seas, all without a single gear turning.
Okay, that explains why it's so much more reliable in a marine environment. You just remove the mechanical point of failure.
You do. But you introduce a brand new challenge. The handoff.
Right, because the satellite doesn't just stay overhead.
No. It's a relay race.
Yep.
Your antenna locks onto a satellite as it's rising over the horizon. It tracks it for a few minutes until it's about to set on the other side. Before that connection breaks, it has to find the next satellite that's rising and hand the data stream off to it seamlessly.
And this happens how often?
Constantly, every few minutes.
That sounds like a recipe for dropped calls. If I'm on a Zoom meeting, am I just going to freeze every 3 minutes?
You shouldn't, but, physics is physics. The source material we looked at notes that these handoffs can cause micro dropouts or a little bit of packet loss. If everything's working perfectly, it happens so fast the software just covers it up. But if there's an obstruction, say, part of the ship's mast blocks the view of the incoming satellite, you might get a drop.
Or if the weather turns. Because we all know satellite TV hates rain.
Water absorbs radio waves. It's just unavoidable. This is called rain fade. In a heavy downpour, that signal has to punch through a literal wall of water.
So in a squall, your speed just tanks.
It will likely drop, or in severe cases, it might cut out. However, Starlink does have a slight advantage here over the old systems. Because there isn't just one satellite to look for, the phased array can sometimes look for a different satellite in a clearer part of the sky. It can kind of dodge the rain cell to some extent.
So it's resilient, but it's not magic.
Correct. And that brings us to, I think, the biggest misconception I see out in the field. People spend the money on the high-performance dish, they mount it on the roof, and then they think they're done.
The router trap.
The router trap, exactly.
I want to spend some real time on this because the installation guides were pretty blunt. They basically said, do not just use the Wi-Fi router that comes in the box. Why is that? If it works in my house, why doesn't it work on my boat?
Two main reasons: materials and density. Your house is probably made of wood, drywall, maybe some brick. Wi-Fi signals can penetrate that reasonably well.
Mm-hmm.
A boat is made of steel, aluminum, carbon fiber.
It's basically a Faraday cage.
It is. It's a shielded box.
Mm-hmm.
If you put that router in the salon, the signal is not getting to the engine room. It's
Right.
probably not even getting to the cabin next door if there's a steel bulkhead in between.
So you have the dish bringing this blazing fast internet to the roof, but you can't actually use it inside the boat.
We see this all the time. An owner complains that Starlink is slow. We look at the data, and the Starlink speed is 200 megabits, but their phone is only getting 5 megabits because they're trying to connect through 3 layers of steel.
So you need a proper network. You need hardwired access points.
You need to run Ethernet cables throughout the vessel and install enterprise-grade wireless access points in every single zone.
Yeah.
But it goes deeper than just coverage. It's really about traffic control.
The sources mention prioritization. Paint a picture of why that matters so much.
Okay. Imagine a scenario. You're the captain. You're navigating a tricky reef pass. You need your electronic charts to update. You need real-time weather radar data coming in. It's safety critical.
Right, absolutely.
At the exact same time, the owner has 3 teenagers on board. One is downloading a massive game update, one is streaming a 4K movie, and the other is backing up their entire photo library to the cloud.
The pipe is completely full.
The pipe is saturated. If you are just using the standard router that comes in the box, it treats all that traffic equally. The captain's weather data has to wait in line behind the video game update.
That seems dangerous.
It's terrible practice.
Yeah.
This is where a professional installation is so important. You need a network router that can handle what we call VLANs, virtual local area networks.
Explain that for the non-IT crowd.
Think of the internet connection like a highway. Without VLANs, everyone is in the same chaotic lanes. With VLANs, you essentially paint concrete dividers on the road. You create a crew lane, a guest lane, and a critical operations lane.
And you can enforce the rules of the road.
You can say the critical operations lane always gets 20% of the speed no matter what, or the guest lane can never use more than 50% of the total bandwidth. So the kids can stream, but they can't choke out the ship's navigation.
That feels like a requirement, not a luxury. If you're running a boat, you need to be in control of that data.
Absolutely. And there's one more layer to this professional setup that the guides really emphasize. Redundancy. We talked about those micro dropouts during handoffs or heavy rain. If you are a charter yacht, guests are paying hundreds of thousands of dollars a week. They do not want their Zoom call to drop, ever.
So you don't just rely on Starlink.
No, no way. You employ a failover system. You keep a 5G or 4G cellular modem for when you're near the coast. Maybe you even keep a legacy L-band satellite connection for pure emergencies.
And the system switches automatically between them.
If you have the right router, usually something called an SD-WAN device, it's seamless. The router sees that Starlink just dropped a packet and instantly routes the next packet through the 5G modem. The user on the Zoom call might hear a tiny glitch, but the call doesn't drop.
It's amazing how much of this comes back to the boring stuff inside the boat rather than the space lasers on the roof.
The space lasers get all the headlines, but it's the cabling and the router configuration that really determine the experience.
So let's talk about the value proposition here, because boats are holes in the water you throw money into, and usually marine grade just means add a zero to the price. How does Starlink compare to the legacy systems cost-wise?
It's disrupted the market completely. In the VS era, you were paying, what, $30,000 to $50,000 just for the hardware, just for the dome. Then you were paying thousands a month for speeds that were barely usable.
And now?
The Starlink high-performance hardware is, well, it's not cheap compared to a home router. It's a few $1,000s. But compared to $50,000, it's a steal. And the monthly service, while it's still expensive, gives you bandwidth that used to be literally impossible to buy at any price.
You're getting so many more megabits per dollar.
Oh, orders of magnitude more.
And this brings up the lifestyle shift. I think this is the part that is hardest to quantify, but maybe the most important. If you can actually work from the boat, if it's not just, I'll check email, but I can run my entire company, that changes how people use their vessels.
It changes the usage patterns completely. We're seeing owners spend weeks or months on board instead of just weekends. But honestly, the biggest impact I've seen is on the crew.
Really? How so?
Think about it. You're a deckhand. You're 22 years old. You're away from home for 6 months at a time. In the old days, you were isolated. Maybe you could send a text message once a week. Now, you can FaceTime your parents. You can watch the same shows your friends are watching back home.
That has to be huge for morale, for retention.
It's the #1 question captains get asked during hiring interviews now. Do you have Starlink? The answer is no. Good luck finding high-quality crew. It's become a basic utility, like hot water.
That's wild. It's gone from sci-fi to a basic utility in, what, 3 years?
It has. But we should temper the enthusiasm with a quick check on geography. We said global, but is it truly everywhere?
I noticed the coverage maps do have some holes.
It works in most coastal and offshore regions, but Starlink needs regulatory approval to beam a signal into a country's territorial waters. There are still countries where it is not licensed. If you sail into those waters, the dish might just turn off.
So it's geofenced.
Strictly. And even in the open ocean, there are still some tiny gaps in the intersatellite laser links. Those are closing fast. And then there's a congestion issue.
Congestion in the middle of the ocean.
Not in the middle of the ocean, no. But picture the Monaco Grand Prix or St. Bart's on New Year's Eve. You have hundreds of super yachts all packed into one tiny bay.
And they are all trying to hit the same 3 satellites that happen to be overhead.
Exactly. Physics kicks in again. Bandwidth is a finite resource. If everyone is trying to stream 4K video in the same square mile, speeds will drop for everyone. That's another reason why those VLANs and those traffic prioritization rules are so critical. When the network gets squeezed, you want to make sure the important stuff still gets through.
It really reinforces the idea that this is a tool that needs active management. It's not magic.
It's a very, very high-performance tool. But like any high-performance tool, it requires a skilled operator and a proper setup to get the most out of it.
So if we boil this down for the listener who is maybe refitting a boat right now, the takeaway is get the Starlink. It's a no-brainer over the old tech, but
don't skimp on the local network. Treat the boat like it's a small office building. Hardwire everything you can. Use VLANs to protect your critical data. And have a backup plan for when the rain sets in. That seems like solid advice. As we wrap up, I keep thinking about that transition. We started by talking about the spinning wheel of doom and the isolation of being at sea.
The forced disconnect.
Right. And there was a kind of romance to it. The ocean was the last place on Earth where the boss couldn't reach you, where the 24-hour news cycle couldn't find you.
It was a true escape.
Now that the boat has the same connectivity as a Manhattan apartment, have we gained functionality but maybe lost the escape? Have we just made the ocean another place to work?
We've certainly removed the excuse. You can't say I didn't get the email anymore. That is a terrifying thought. Maybe the ultimate luxury in the future won't be having the connection. It'll be having the discipline to turn the router off.
Now, that is a challenge much harder than the engineering.
Something to think about. Thanks for walking us through the wiring diagram today.
Anytime.
We'll catch you on the next deep dive.